stripping the metal cladding, referred to as MC, of electrical cable and pushing it into a pipe is a violation of the National Electrical Code, or NEC. Article 330.10 requires that MC cable be protected from physical damage. Article 330.15 requires that MC cable be terminated in an approved manner. Article 404.9 requires that all conductors in a raceway be insulated and protected. By stripping the MC cable and pushing it into the pipe, a situation is created where the conductors are not properly protected from physical damage or insulation failure. This could lead to electrical hazards such as short circuits, electrical shocks, and fires. Additionally, by concealing the uninsulated conductors in the pipe, it is difficult to inspect and maintain the electrical system, increasing the risk of undetected problems. The correct way to terminate MC cable in a box is as follows. 1. Cut the cable to the desired length, leaving approximately 6 inches of excess at each end. 2. Remove the outer jacket of the cable for a distance of approximately 3 inches, exposing the individual conductors. 3. Strip the insulation from the end of each conductor for about 1/2 of an inch. 4. Connect the conductors to the appropriate terminals in the electrical box using approved connectors, for example wire nuts or screw terminals. 5. Secure the cable in the box using a cable clamp or other approved method. 6. Replace the cover plate on the electrical box. It is important to always follow the National Electrical Code and local electrical codes when performing electrical work. Failure to do so can result in serious injury or death. MC cable, or metal-clad cable, is a factory-assembled cable consisting of one or more insulated conductors enclosed in a metallic sheath of interlocking tape or smooth or corrugated metallic tube. MC cable is used for power, lighting, and control circuits in a variety of applications, including residential, commercial, and industrial buildings. It can be installed in dry or wet locations, and can be concealed or exposed. There are several types of MC cable, including the following. Firstly, AC, or armored cable, which has a flexible metallic sheath and is suitable for dry locations. Secondly, MC, which has a corrugated metallic sheath and is suitable for dry or wet locations. Thirdly, HCF, or healthcare facilities cable, which has a smooth metallic sheath and is designed for use in healthcare facilities. The National Electrical Code, or NEC, provides specific requirements for the installation and use of MC cable. These requirements are intended to ensure the safety of persons and property from hazards arising from the use of electricity. Some of the key requirements for MC cable include the following. 1. MC cable must be supported at intervals not exceeding 6 feet. 2. MC cable must be protected from physical damage. 3. MC cable must be terminated in an approved manner. 4. MC cable must be grounded in accordance with the NEC. 5. MC cable must not be installed in hazardous locations unless it is specifically listed for that purpose. When installing MC cable, it is important to follow all applicable codes and standards. It is also important to use the proper tools and equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician. The metallic sheath of MC cable provides a continuous grounding path, which helps to protect against electrical shock. The interlocking tape or corrugated metallic tube construction provides physical protection for the conductors inside the cable. MC cable is relatively easy to install compared to other types of wiring methods. MC cable is available in a variety of sizes and conductor configurations to meet the needs of different applications. When selecting MC cable for a particular application, it is important to consider the following factors. Firstly, the ampacity of the conductors. Secondly, the voltage rating of the cable. Thirdly, the environmental conditions. Fourthly, the type of occupancy. Fifthly, the applicable codes and standards. The ampacity of a conductor is the maximum current that it can carry continuously without exceeding its temperature rating. The ampacity of MC cable is determined by the size and type of conductors, as well as the ambient temperature. The voltage rating of a cable is the maximum voltage that it can withstand without insulation failure. The voltage rating of MC cable is typically 600 volts. The environmental conditions can affect the performance and lifespan of MC cable. For example, MC cable installed in a wet location must be listed for wet locations. Type of occupancy can also affect the selection of MC cable. For example, healthcare facilities require special types of MC cable that are designed to minimize the risk of electrical shock. The applicable codes and standards provide specific requirements for the installation and use of MC cable. It is important to follow all applicable codes and standards when installing MC cable. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. The NEC is updated every 3 years, and it is important to stay up to date on the latest requirements. In addition to the NEC, there may be local electrical codes that apply to your area. It is important to check with your local authorities to determine the applicable codes. When working with electricity, it is important to take safety precautions to protect yourself from electrical shock. Some safety tips include the following. Firstly, always turn off the power before working on electrical circuits. Secondly, use insulated tools. Thirdly, wear rubber gloves and shoes. Fourthly, never work on electrical circuits in wet conditions. Fifthly, if you are not comfortable working with electricity, hire a qualified electrician. Short circuits can occur when there is a low resistance path between 2 points of different potential in an electrical circuit. Short circuits can cause a large amount of current to flow, which can damage equipment and start fires. Electrical shocks can occur when a person comes into contact with a live electrical conductor. Electrical shocks can cause muscle contractions, burns, and even death. Fires can be caused by electrical short circuits, overloaded circuits, and faulty wiring. Electrical fires can spread quickly and are difficult to extinguish. Proper grounding of electrical systems is important to protect against electrical shock and fire hazards. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shocks. Electrical inspections are performed to ensure that electrical systems are installed and maintained in accordance with applicable codes and standards. Electrical inspections can help to identify potential hazards and prevent electrical accidents. If you are planning to perform electrical work, it is important to obtain the necessary permits from your local authorities. Permits are required for most types of electrical work, and they help to ensure that the work is performed safely and in accordance with applicable codes. When hiring an electrician, it is important to choose a qualified and licensed electrician. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly. A licensed electrician has met the requirements of the state or local licensing board. When selecting an electrician, it is important to check their qualifications and references. It is also important to get a written estimate before the work begins. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost of the project. MC cable connectors are used to terminate MC cable to electrical boxes, enclosures, and other equipment. There are different types of MC cable connectors available, each designed for specific applications. Some common types of MC cable connectors include the following. Firstly, squeeze connectors, which use a screw to tighten the connector onto the cable. Secondly, set screw connectors, which use a set screw to secure the cable in the connector. Thirdly, snapping connectors, which snap into place without the need for tools. Fourthly, liquid-tight connectors, which are designed to prevent the entry of liquids into the electrical system. When selecting MC cable connectors, it is important to choose connectors that are compatible with the type and size of MC cable being used. It is also important to choose connectors that are listed for the intended application. MC cable tools are used to cut, strip, and terminate MC cable. Some common MC cable tools include the following. Firstly, cable cutters, which are used to cut MC cable to the desired length. Secondly, cable strippers, which are used to remove the outer jacket of the cable. Thirdly, cable benders, which are used to bend MC cable to the desired shape. Fourthly, conduit benders, which are used to bend conduit. Fifthly, fish tapes, which are used to pull wires through conduit. When using MC cable tools, it is important to follow the manufacturer's instructions. It is also important to wear safety glasses and gloves to protect yourself from injury. The proper support of MC cable is essential for ensuring the safety and reliability of the electrical system. MC cable must be supported at intervals not exceeding 6 feet. The supports must be designed to prevent damage to the cable. Some common methods of supporting MC cable include the following. Firstly, cable ties, which are used to secure the cable to a support structure. Secondly, cable clamps, which are used to clamp the cable to a support structure. Thirdly, staples, which are used to staple the cable to a wooden support structure. Fourthly, hangers, which are used to suspend the cable from a ceiling or other overhead structure. When supporting MC cable, it is important to ensure that the supports are properly installed and that they are not over-tightened. Over-tightening the supports can damage the cable and reduce its lifespan. The National Electrical Code, or NEC, provides specific requirements for the grounding of MC cable. Grounding is the process of connecting the metallic parts of an electrical system to the earth. Grounding helps to protect against electrical shock and fire hazards. The NEC requires that MC cable be grounded in accordance with Article 250. This article provides specific requirements for the size and type of grounding conductors, as well as the methods of grounding. When grounding MC cable, it is important to follow all applicable codes and standards. It is also important to use the proper tools and equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. Overloads occur when a circuit carries more current than it is designed to handle. Short circuits occur when there is a low resistance path between 2 points of different potential in an electrical circuit. Overcurrent protection devices are designed to trip or blow when the current in a circuit exceeds a certain level. This helps to prevent damage to equipment and start fires. The National Electrical Code, or NEC, provides specific requirements for the selection and installation of overcurrent protection devices. These requirements are intended to ensure that the devices are properly sized and installed to protect the electrical system. When selecting overcurrent protection devices, it is important to consider the following factors. Firstly, the ampacity of the circuit. Secondly, the voltage rating of the device. Thirdly, the interrupting rating of the device. Fourthly, the type of occupancy. The ampacity of a circuit is the maximum current that it can carry continuously without exceeding its temperature rating. The voltage rating of a device is the maximum voltage that it can withstand without failure. The interrupting rating of a device is the maximum current that it can safely interrupt. The type of occupancy can also affect the selection of overcurrent protection devices. For example, healthcare facilities require special types of overcurrent protection devices that are designed to minimize the risk of electrical shock. Electrical boxes are used to enclose electrical connections and protect them from damage. There are different types of electrical boxes available, each designed for specific applications. Some common types of electrical boxes include the following. Firstly, metal boxes, which are typically made of steel or aluminum. Secondly, non-metallic boxes, which are typically made of plastic. Thirdly, weatherproof boxes, which are designed to protect electrical connections from the elements. Fourthly, floor boxes, which are designed to be installed in floors. When selecting electrical boxes, it is important to choose boxes that are compatible with the type and size of wiring being used. It is also important to choose boxes that are listed for the intended application. The National Electrical Code, or NEC, provides specific requirements for the installation of electrical boxes. These requirements are intended to ensure that the boxes are properly installed and that they provide adequate protection for the electrical connections. When installing electrical boxes, it is important to follow all applicable codes and standards. It is also important to use the proper tools and equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Conduit is a raceway that is used to protect electrical wires from damage. There are different types of conduit available, each designed for specific applications. Some common types of conduit include the following. Firstly, rigid metal conduit, or RMC, which is a thick-walled steel conduit. Secondly, intermediate metal conduit, or IMC, which is a thinner-walled steel conduit. Thirdly, electrical metallic tubing, or IMT, which is a thin-walled steel conduit. Fourthly, flexible metal conduit, or FMC, which is a flexible metal conduit. Fifthly, liquid-tight flexible metal conduit, or LFMC, which is a liquid-tight flexible metal conduit. Sixthly, rigid non-metallic conduit, or RNC, which is a rigid plastic conduit. When selecting conduit, it is important to choose conduit that is compatible with the type and size of wiring being used. It is also important to choose conduit that is listed for the intended application. The National Electrical Code, or NEC, provides specific requirements for the installation of conduit. These requirements are intended to ensure that the conduit is properly installed and that it provides adequate protection for the electrical wires. When installing conduit, it is important to follow all applicable codes and standards. It is also important to use the proper tools and equipment. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Wire connectors are used to connect two or more electrical wires together. There are different types of wire connectors available, each designed for specific applications. Some common types of wire connectors include the following. Firstly, wire nuts, which are used to connect two or more solid or stranded wires together. Secondly, crimp connectors, which are used to connect two or more stranded wires together. Thirdly, push-in connectors, which are used to connect two or more solid wires together. Fourthly, split bolt connectors, which are used to connect two or more large wires together. When selecting wire connectors, it is important to choose connectors that are compatible with the type and size of wires being used. It is also important to choose connectors that are listed for the intended application. When connecting wires, it is important to follow the manufacturer's instructions. It is also important to make sure that the connections are tight and secure. Loose or corroded connections can cause electrical problems and even fires. Always refer to the latest edition of the National Electrical Code for the most up-to-date regulations and safety practices. This information is for general guidance only and should not be considered a substitute for professional electrical advice.